Let's go back to 16. Sorry, did I say 14? I meant 16. Maybe I need some sleep. Who knows? We talked about normal CDF and inverse norm. You're going to have to decide which one to use. When? There's only one of them. You can't use them both at the same time. So either this one or it's this one. I'm using a different highlighter to re-emphasize certain things. How do you know to use normal CDF, guys? That giveaway will calculate the probability of data. So it will calculate the probability. And what's probability usually given as? Percent. So if the question asks you what percentage, right? You know normal CDF. That's the one you have to use. Versus inverse norm, it will calculate the actual value. So it will give you a percentage, and I will say, well, what value would fit this criteria? Okay, what height, what test score, what, right? You name it. What weight? So it's actual value, probability, right? Gives probability, gives the actual value. So that's how you know. Another thing I want you to really emphasize here is, remember this. If you're given a z-score, right, then that's what you know, right? Average is 0, standard deviation is 1. Please remember that. And then the other thing is very important here. If you have a different highlighter, that'd be much better. Inverse norm I need to add something. Whew, good thing I noticed that. So add to your notes. Oh yeah, it's there. Sorry. Inverse norm. You're the first group that gets this handout, so I'm not copying my notes here. Percentage of data below, guys, to the left. Think of that song, right? To the left, to the left. You want everything to the left. Okay, so what do I mean by that? If the question gives you 35, like 35 students score more than this, you want to focus on, well, how many would be scoring below, which is 65, right? You earn less. You're worried about how many percentage-wise, what is below that given value you're interested in. Let's go over to the right, to this one here. You are interested in this one, always. For inverse norm, let's do this here. Right? Make it cheesy as possible. That usually sticks, right? Think of inverse norm. Oh yeah, I need everything to the left, right? So if 80% of families earn more than $30,000 a year, right? What are we interested in? 80% score more, so 20% earn less. That's the one inverse norm wants to know, right? So let's do an example here. Potato chips, right? Potato chips. If you like potato chips like I do, right? This question is going to be very applicable to you here. Potato chip, they have a mean weight, right? There's that mean weight of 250, that's X bar, and a standard deviation of 5 grams, perfect, that's given to us. Weights of a bag, the weights of the bags follow a normal distribution. They're telling you, right, that this data that we're dealing with follows that normal distribution. What does that mean? Bell curve, right? 68, 95, 99. That's what that means. Okay, sketch the normal curve indicating the percentages within plus or minus, and I'm just going to do this really quick because I actually am not going to use this other than to just make reference. So I'm going to find my middle, go up. That's the highest point. Most data points will be in there, and then just taper off like this and do the same thing there, and try to find a consistent increment for those. So let's see, 1, 2, 3 works perfect. I'm using 2 centimeters at a time, and that seems to work just fine. Okay, so 34, 34. See, I'm also at the same time making you use these values over and over so that you know how that works. And so we just simply put the 250 here, go down by 5 in this case. I picked an easy number just to make it quick, right? So we're going up by 5 and down by 5. Make sure these numbers, they line up. They line up with these lines that you've made, okay? And every single value, guys, just so you know, there are values everywhere in between here. We can't label them all, right? It's impossible. But every single value has a z-score. The ones we know for sure are the ones that fall right in with the standard deviation, not standard deviation, right? Like the values here, right? So a 1, 2, and 3 going to the right, -1, -2, -3 going to the left. So these are my z-scores. And here I will put down the weight in grams. Okay, you need to have that there. If your data has units, right, label it and make sure it never touches the x-axis. Yes. Oh, yeah, that's right. 65, sorry. Thank you, Damon. I don't know what's wrong today. In the morning, I had several of those. Time to retire. All right. So, okay. Also, to speed things up, I tend to at least have the 68 there and the 95, perhaps, right? That tends to speed things up for answering. If you can, I don't require that, to be honest. As long as you have the numbers in between the intervals, you're fine. But we know that, let me have 2 pencils here. If you take the average in the middle, if you go within 1 standard deviation on either side, that's 95. If you go within 2 standard deviations, this is 68, 95, 99.7, right? Within 3 standard deviations. So that's what you will observe when data is normally distributed, okay? It's not always the case. I will show you. If you were to plot my marks after marking a test, not always normally distributed. It's like all over the place, like it's not a nice curve if I were to graph it. And we'll discover that a little bit later. Okay, now let's go to page 17. If you can have it open and see the graph, that would be great, but I don't know what your space is like. But watch this. Use technology to answer the following. I don't want you to use the graph, not the graph. Okay, I don't want you to use the graph, and there will be several ways that you're going to find out, oh yeah, I can't use the graph. It doesn't really work. Okay. Okay. So please follow me. This is important. If you can wrap your head around this, that's what we're going to do quite a bit moving forward. So try to stay with me as much as you can. Okay. Calculate the probability percentage. That is a hint for normal CDF. That is a hint. It's a dead giveaway. It's not asking for the actual value. It's saying, hey, what's a probability? Remember, those percentages are all probabilities. They're all like likelihoods of bags weighing between, right, 232 and 273. This is going to be my lower limit, and this is my upper limit. Both are in this case provided. Are these values on my graph on the back side? Check. Is there 232 on the curve along the x-axis? No. Is there 273? No. They're always by fives, right? So that should be an indication, like I can't use my curve for this. I can't. I just can't. So we're going to use normal CDF. So normal CDF, right? And we're going to, it needs four things. It needs the lower value. It needs the upper value. It needs my mean, which is, was it 250? Pretty certain it was 250. And my standard deviation is 5. And watch this. I multiply that answer by 100. Because as it stands, it will give you a decimal. You want to go get your percentage. So we're going to go, right? We're going to find that answer. So how do you get that again? It's second vars. You got to press second vars. Vars is right next to clear. And then select normal CDF. And then it's 232, comma, 273, comma, 250, comma, 5. You can close your bracket there and just hit enter. And that's quite a few of them, isn't it? So we're going to multiply that by 100. That would be 99.98%. I want you to round to 2 decimals, okay? Of bags. Let's check if this makes sense. 99, that's like almost everything, right? And so that's the only reason why I wanted you to graph this. 232, 273, remember that? 232 is like it's somewhere over here, correct? So that's one limit. So between there and 273, where's 273? It's like way over here, right? So it is indeed almost the whole curve. Not quite 100%, but very close. So this makes sense, right? It should make sense. Let's keep going. Calculate the percentage. There it is again. The percentage. I'm asking you to calculate. That's another giveaway. Percentage of bags heavier than 257. What's that? Heavier than this. So you want 257 grams plus, right? 257 or bigger. So this is actually, right? This is actually the lower. This is the lower limit. They don't give you an upper. It's almost like infinity, right? So this tells you normal CDF. So I'm just going to go like this. Normal CDF. And I get my my lower. Do you remember what I said yesterday? Did I mention 10,000, 100,000, a million? You pick. But something significantly bigger than what you have, because it's going to be so far down the x-axis that it's basically going to include everything. Okay, 10,000. This is my upper limit because you got to give it something or else the calculator doesn't know what to do with it. And we're going to multiply that by 100. And so multiply that by 100, you get 8.08% of bags are going to be heavier. I expect it to be heavier than 8.08%. Oh, sorry, than 257 grams. Let's verify this. I don't want you to blindly trust because sometimes students get a completely wrong answer and never even second guess, right? So remember 257, right? We're going to go over here. 257 is there somewhere. And does it make sense? 257 is right about there. So this would be 2.5 and then some. You cannot split 13.5 in half. You cannot say if I'm about there, it's this split in half. Why not? It's not a rectangle, right? It's tapering off here. So this chunk is actually a little bit smaller than half of that, right? So it makes sense. It makes sense. This makes sense. I'm just double checking. Okay. Next, calculate the percentage. Percentage of bags weighing less than that. So it's basically saying 243.5 or less, right? That's what it's saying. So what limit is this? It's the upper. That's what I need right now. I just need an S in front of it. It's upper. That'd be pretty good right now. Anyways, normal CDF. Why? Because it's percentage. Okay, so this is, what do I do now though? I will go negative 10,000. I'll go negative 10,000. All the way to 243.5. And remember, standard deviation and the mean stay the same for all of these questions. So let's try that one. So negative 10,000, make sure you don't use takeaway because it's going to give you an error if you do that. It's not going to like it. Times 100, I get 9.68% of bags are likely to weigh less than that. All right. Do we want to double check or do you just trust me already? 243 is right about there. So it makes sense that it is right in the 9.6. So keep that in mind. E, this one is trickier now, okay? So I purposely worded it in a certain way so that we get the difficult ones in class, okay? Company disposes of any bags weighing less than 239. So this is going to be a category here. And any bags weighing more, right? More than 262 grams. So it's saying we're trimming off on the low end and we're trimming off on the high end. We don't want that, right? Because if you do too low, the customer is going to feel ripped off. I always weigh my bags before I eat them. I'm just kidding. And if it's more, then the company loses, right? Like if they put too much in there, then they lose it, right? Because it's obviously. What percentage of bags would the company dispose of? Percentage. So watch this, folks. I'm going to do two normal CDFs here. I think you can handle it. Normal CDF Let's tackle this one. Let's find percentage to the left, less than this. So negative 10,000 all the way to 239, 255. Okay? And then I'm going to do another normal CDF. And now I'm going to tackle this one. That one, you have to be careful, right? 262 is the low end, and now you want to get everything higher than it. So you go 262 to 10,000, 255. Because these are your notes, I'm going to do this here. I'm going to just on the side, allow me to do this less than 239, and this is more than 262. Okay. Less than 239, more than 262. Let's figure that out on the side here. So second vars, if you can follow with your calculators, if you can. If I'm writing a little bit too fast, then if you need to write this down, then go for it. So I'm going to do the first one here. I'm not going to times it by 100, okay? I'm just going to go, I figure out that it's this. That way I can go second enter and just do this whole thing again. So I'm going to go 262, comma, 10,000. I'm just going to go 100,000. Now I'm going to go times 100. This is, watch this, 0.82%. Right? If you multiply that by 100, it's a very small amount of bags, right? But that's, so we need to figure out, we need to add this, right? We're going to add these two together. And so 1.39, we can do this, right? 112, 2.21% of bags will be disposed. Let me just, anybody think of a different way of doing this? Because there's another way. Yeah, 1 second, Damon. There. Yeah, go ahead.
Finding the base that they know exposed up and then minus that by 100%.
That's right. Yeah, go ahead. Yes, and I don't have room to do this here, so I'm gonna have to grab it. This is important. It's gonna save. It won't save your life, but it will save time. Here, you know what we did here just now? We figured out what goes from the left and what goes to the right. Right? We figured this out, and then we added that to get the percentage that gets disposed of. And we knew that this was from 239 to 262. What if I told you that we could actually just find, because this was 1.39% here, and this is 0.82%. What if I told you that we can just find what the ones that are not disposing of, and just subtract that from 100 and get our answer that way? So let's try that. Normal CDF. I'm just going to go from 239 to 262, 255. Like if I go from here to here, and find the percentage of bags that are kept. Does that make sense, or am I talking nonsense here? But if I go second vars, normal CDF, 239, 262, 250, 5. Watch what I get. I get 97.79% if I rounded that. So when you then go 100 minus 97.79, you get 2.21 as well. So there are two ways to get there because you know that the curve is always 100%. So you either find what you want to dispose of, or you find the ones you keep and then subtract it from 100. You get your answer either way. Yeah.
In my questions during the test quiz you ask, would you be asking for a specific way or
No, no. I will not be asking for a specific way. No. If you see this, go for it. Like if you see that, just go for it. And there will be examples where I will show you the other way. Okay. Think of this is grade 12 stuff. There's direct reasoning and then there's indirect reasoning. This is direct, like you're tackling it and then your answer is the answer. The other way is indirect reasoning. More next year. Okay. What are we time wise? We're doing okay. I want to finish this. So let's see. If the company produces 5,400 bags per day, how many bags would be removed from the production line? This is just a simple, we use the 0.0221, which is that divided by 100, times the number of bags. So sometimes it's a separate question, sometimes it's all in one. And that's 119. I like that this is a decimal because we can't answer that. So we would say, what would you say? I would say 120 bags, just to be safe, right? Like if you're removing, I rather remove a little bit extra to make sure we account for the loss, right? I want to use inverse norm soon, so I think I might skip a few. What percent of bags have a weight of a z-score of this and this? Z-score, do you remember that? I told you. If you get that, what's the mean? And the standard deviation? Sorry, the mean is 0, the standard deviation is 1. Yeah. When you see z-score, this is true. So watch this, normal CDF. Between 0.6, right? Between negative 0.6 and 1.34, and then you just go 0, 1. Multiply that by 100. (63.56%). Think about it. A z-score of negative 0.6 is just to the left of the mean, right? And 1.34 is past to the positive. So between these two values, does it make sense to have 63.56%? Let's check that. Negative 0.6 would be right about there. 1.34 would be right about there, right? So we almost have 68 here already, and then some, right? So it does make sense to be in the 60 somethings, right? Just to double check. Calculate, watch this, the actual weights that correspond to each z-score above. What's the percentage of bags between these? Would the percentage of bags between these be the same? What would you say? If I take the actual weights or the z-scores, would you get the same 63.56? The answer is yes. Yes. I want you to see that because we're going to use that later on. So let's figure that out. A z-score of negative 0.6, let's figure out the actual weight. You have to use this formula. So we're going to go negative 0.6 times the standard deviation is 5 plus 250. And I will just figure that out. That's negative 0.3 plus 250. That's 247 grams. And a z-score of 1.34, I would go 1.34 times the standard deviation of 5 plus 250. After today, guys, after this lesson, you need to sit down and figure that out. Figure this out, okay, for yourselves. Wrap your head around it. So I'm going to go normal CDF between 247 and 256.7, 250, and 5 times 100. And I know I always tell you to just trust me, but I honestly want you to see it for yourself. And I know I'm way too excited for something as boring as stats, right? But there it is, folks. Same. Now we're ready for inverse norm, I think. We're ready to take this further. And then that'll be it. Yeah.
I'm a bit confused on how come we have on F the standard deviation and the mean is 0 and 1, but then when we go to the actual question, we immediately go back to 5 and 250.
Yeah. Because you're trying to transfer the z-score to the actual value, right? Then you want to use the standard deviation and the mean for the value, right, that you're trying to find for.
And then where did you get the 0 and the 1 for F?
Because here they just asked me, hey, what percentage of bags is in between here? You're using z-scores. You're now going to stay within the z-score to figure out the percentage. And so you use 0 and 1. Because if you use 250 and 5, right, you would try to find the weight of a bag of negative 0.6 grams and 1.34 grams, which can't be, right? So it has to be in this case, as soon as you get z-scores, just use 0 and 1. But when you're trying to go from z-score to whatever, this could be dollars, this could be centimeters, inches, whatever, then you use the average, whatever the average is, let's say $30,000 and standard deviation of 15,000, just use that in this calculation. Does that make sense? Maybe the time. Yeah. If you use 0 and 1 there, let's try 0 and 1. You would get negative 0.6. Yeah, it would just be negative 0.6 all over again, right? So you can't use that there. Okay, hold on. Don't back. Here, I need you to have a few inverse norms, otherwise you're not going to be able to do the homework. I know. I can't wait till summer break. You can't wait. We all can't wait. Page 18, okay, please. The company would like to know the weight, not the percentage. Would like to know the weight, the actual weight that would place 65% of bags produced below this weight. You got to use inverse norm. You got to use that one because they're asking you to figure out the actual weight. Can you just do this real quick? Just do a small little bell curve there. 50% would be about half, right? You have 50 and 50, right? This is where a value would be located. But if 65% of bags are below this weight, where would you have to move that line to? You would have to move it slightly to the right, because that would mean that 65% are below that weight you're interested in. The word below, right, tells you that the 65% is to the left of it, which means the actual weight needs to be positioned above the mean. So 65% is exactly what we want. Watch this. Inverse norm. You got to plug that in as a decimal. And you got to give it the standard deviation, the mean and standard deviation just like before. Let's go ahead and find it. Second vars, inverse norm, 0.65, 250, and 5. That is, watch what you're finding now is in grams. So you found that weight, and this weight, a bag weighing this much would put 65% of the bags below that weight. 65% of the bags would weigh less than this. One more. I promise one more, and then we pack it. Company would like to know the weight. The actual weight would put 6% of the bags produced as heavier than it. It would put 6% of the bags above it. So watch this. Put this here. Remember, if the weight would be in the middle, you'd have 50 to the left, 50 to the right. But they're saying that 6% would be heavier than this. So you would have to move this up. Oops. Where 6% of the bags are heavier. So how many are lower? Because that's what inverse norm wants. 100 minus 6, that's 94%. So inverse norm is 0.94, 250, 5. I'm going to call it again. Second enter. I'm just going to change that 0.65 to 0.94. And that's 257.77 grams. So you're finding the actual weight of the bags. Okay. Okay. I didn't mention yesterday, but we're gonna have our quiz on Monday. I'm gonna do more of this tomorrow, but I will already hit you with an AC tomorrow on this stuff. So there's the homework down there. It's in the textbook. The answers are at the back. Thank you, guys.